Land is a portion of the world not covered by water, and the soil is part of the land. Okay, soil is a mixture of minerals. We're going to talk about minerals later. Organic material, living organism, air, and water that together support growth of plant life, and also other forms of life, I would say. And a good agriculture soil has 45% of mineral, 25% of air, 25% of water, and 5% of organics. And you can see the air is very important here. I want to point out because good soil has good aeration and it feels soft and crumble. It's not very tight, very solid. That's bad soil. So for the soil to support the life, it has to have a decent amount of air and water. Humus is organic material. Sometimes we see this very loose, puffy, black material in the soil. That's part of the organics in the soil. And it's from the decay of plants and animal remains, and they are very important. Okay, they have the nutrients and they create a crumbly soil that allows adequate water absorption and drainage. Soil structure refers to the way various soil particles clump together. And the good soil, ideal soil, usually have a very good aeration and drainage properties. And in the good soil, 1/2 to 2/3 of spaces contain air after the excess water has drained. Okay, so it's porous, okay, and it's friable, which means that it crumbles easily. Those are good soil. The bad soil is hard, okay, and clumped together really tight, and no space for air and the water. Those soil are really bad. Now, what is soil texture? Soil texture is determined by the size of mineral particles within the soil. If there's too many large particles, that leads to extreme leaching, so that soil does not contain any nutrients. That makes sense, right? The sand, you put the water through the sand, everything drain, nothing stay. And too many small particles in the soil lead to poor drainage, right? That leads to no space for air and water. And I'll offer a bonus activity here. You can do a simple experiment in your home. Basically, I'm going to ask you to have a decent bottle. The best bottle is from the buy teas. you can buy those from all the grocery store. A bottle with a flat bottom, and then you label the upper limit of the bottle, and then you fill half of the bottle with the soil, ideally your garden soil, okay? And then you put water in the plastic bottle and mix them really well and get rid of the bubbles and let it sit overnight or over at least 2 to 3 hours, and you measure the length of each layer, and after you get those parameters, you can map out this chart and see what kind of soil that is. If you don't have garden soil, you can just dig any soil close to where you live or where you work, and that will work. And the best soil we say is a loam, because the loam have an ideal combination of everything, of the air and the water, humus, organic matters, and the minerals. And this will be fun. This is a bonus activity. And I probably will post a video how to do this chart. Basically, you have to calculate like each layer was a percentage of the total length. After you get that percentage, you can put those 3 numbers and then put a parallel line along each side of the triangle, and that will map out what kind of soil you have. So soil, is soil dirt? No. No. Why not? Watch this video. So I talk about the soil texture, and now soil profile. Soil profile is a series of horizontal layers. Okay, each recognizable layer of the profile is known as a horizon. And what is leaching? Leaching is a drainage of the nutrients by movement of water. This probably look very overwhelming. Now let's split this graph into two parts, the left side or the right side. The left side is my favorite picture to illustrate the soil profile, and the right side is to help you to understand what is leaching. Okay, let's look at the simple side first. Zone of leaching, that means when it's raining, okay, when it's flooding, or the snow melting, we have the water moving downwards and carry all those minerals and nutrients into deeper layer of the soil. And here it cannot drain anymore. We'll see why it cannot drain anymore. Okay, but now I just want you to remember it cannot drain anymore. So all those nutrients are kind of accumulated in this layer. Okay, this is a graph from our textbook. And look at the left side. This is profile of soil. Ignore the right side and the left side. Let's just concentrate on the middle. Okay, it has a layer of organic matters. Okay, there's M breakdown. I would say undecomposed organics and composed organics. Together, it's called O layer. I expect you to understand this, okay? The very upper layer with a lot of organics is called O. And then we come to this A layer, the A horizon. This is very important. That's the top soil. This is most active layer of soil. And how good, how fertile the soil is decided by A layer. Okay? And then forget about E. Okay, our textbook require you to know O, A, B. B is a subsoil. That's a horizon of accumulated suspended materials from above. I would say B layer is this layer. Okay, and the E layer, if you're curious, E layer is this leaching layer. Okay, B layer is a subsoil and with accumulated minerals. And this is a C horizon, that is weathered parent material, which is a rock. Okay, that's the weathered rock. And the bottom is the bedrock. Okay. So our textbook have this simplified graph. So A is a topsoil, O is the organics, and B is a subsoil, and the weathered bedrock, and the bedrock. Okay, I only expect you to remember what is A, O, A, B, C. Most important is O and A. All right, I will conclude here.